All right, now that I have my epicenter triangulated on my map, now I want to take that epicenter and extract some data from it so that I can give it to someone else and they will end up with the same epicenter, one really close to what I did. So let's take a look just to review here. This is the epicenter I chose. Pick 3 cities. I have some information down here. What I'm going to do before I take the data is just remind myself which city had which data. Like this was the distance from the epicenter to Minneapolis. I don't want to forget that and make a mistake later and misidentify that city. This one was my epicenter distance to Cancun, and this one was my epicenter distance to Fairbanks. So I have the 3 distances here, and can now start to take a look at this because one of the columns we have says distance to epicenter. So this I can now fill in because I have those already. You can actually put your stations in any order you want to. I'm just going to do it in the same order that I plotted them in so I don't confuse myself. So I'm going to put this as Cancun, first station. I'm going to put Fairbanks as my second, and Minneapolis as my third. Now I know what my epicenter. I know what my distances to my epicenter are because I have them right here. So Cancun is 1,800 kilometers, so I can put that number here now. Fairbanks was 2,500, so that can go here. And Minneapolis is 1,000. No, I'm sorry, it wasn't 1,000. That was my scale. 850. See, I'm happy I drew that little arrow. I would have made a mistake right there, which would have thrown off my data. So now that I have some epicenter distances, I can now find my P-wave travel time because that's just a matter of finding that distance on my reference table and going up to the P-wave line and across. So my first one says 1,800, so what I'll do is I will go to 1,800, which is right here, and I'm going to go up to my P-wave line and across. Okay, so here and across. So what I'm getting right here, I'm just going to check it one more time. Looks like I'm getting about 3 minutes 40 seconds. So 3:40. So I'll write here. You can also write it in the other format I showed you, which is like this. Sometimes that's a little less confusing. Now I'll take a look at Fairbanks, which is 2,500. I'm just going to choose here right next to it. For 2,500, I'm going to go right in between the 24 and the 26. I'll go up, and it looks like I'm getting about 4 minutes and 50 seconds. And Minneapolis is 850. I'm just going to say 800. And we'll go up to here, and it looks like we're getting about 1 minute 50 seconds. Okay, I want to be able to go and fill all the rest of these things in, but I'm not going to do that just yet. I mean, you could go here, but what I'd like to do instead is I'm just going to choose an origin time for my earthquake. Now, you can be very arbitrary about this because you have not made your seismograms yet. I decided to choose 4 o'clock. 4 o'clock is the time that I like to get up in the morning, so it's one of my preferred times of the day because I feel like the whole potential of the day ahead of you. So 4 o'clock as my time of the earthquake. And I'm putting this here because this is where I want my data to end up. Remember, the earthquake is an event, so all 3 of these should be very close to the same time. I'm just going to make them the same time right now, and I can do that. So now what we can do is I can take this and figure out my P wave arrival time because I have my travel time. So the earthquake happens here, and it took 3 minutes and 40 seconds for the P wave to arrive at Cancun. So what that's going to make this is going to make it 4:03:40. And Fairbanks, it took 4 minutes and 50 seconds for it to get there, so that's going to take this and make it 4:04:50. I'm just taking this time and adding it to this one. Remember, this is 4 minutes and 50 seconds. This is 4 hours and 0 minutes. That's why maybe putting it in this format for some people might be better, so that you don't confuse yourself. Either way, if you can handle it like this, it's fine. If not, write it like that so you don't make any mistakes. 1 minute and 50 seconds for the P wave travel time. So I'm going to add that to my 4 o'clock, and I'm going to end up with 4:01:50. Perfect. My S wave arrival time, I don't really have a column on here for S wave travel time, but I can figure this out a bit just using the wedge method here. So I have distances here. I have 1800. What I can do with 1800 is I can come up to here now. Put this on the screen. 1800, I can come up to here and figure out my difference, my time difference, which is looking like it's 3 minutes. So I can put that here. Because that's a difference of 3 minutes, I know the S wave is going to arrive after the P wave. I can add this to this, because what we're saying is that, okay, the P wave arrived at 4:03:40. It took another 3 minutes for the S wave to arrive, so that can make this 4:06:40. Fine. We can do the same thing for Fairbanks at 2500. So I'm going to find my 2500. It's right about here. Grab my piece of paper. Determine my difference, which is looking like it's 4 minutes. And we're going to add that to this, which is going to make it 4:08:50. Do it one more time. 850 in Minneapolis. Again, I'm going to choose 800. I think it'll be close enough, and that it won't really impact anyone finding my epicenter. So it's like we have 1 minute and, sorry about that, we're off screen. We have 1 minute and 20 seconds. I got that by going right here. 800. About 1 minute. It's like 1 minute and 30 seconds, really, if I look real close. So I will put that as 1 minute and 30 seconds. And that is going to make this one 4:02:20. So now I have everything that I need to draw my seismograms, which is my next task. So here on the next page, you are going to make your seismograms for someone else to read. You do not need to fill this in. This is what the person who will solve your epicenter problem will do, but you could put your name here. So I would put Mr. Gulwitzer right there. Then if I were to give this to whoever, if I gave it to Mr. Rada, he would put his name there, and then he would go about solving it. But I have to give him the seismograms to solve. Now, just a reminder, seismograms look like this. Generally, here's some that I drew. I put the city, I put a time scale on the bottom, and then I also marked where the P wave arrived and the S wave arrived. So to do this, I want to take a look at the data I have here. So this data here is telling me about how long I need to make my scale and the divisions I need in here. So it looks like my earliest time is 4:01. I'm probably going to put 4 o'clock as the beginning of mine. Looks like I need to go up to maybe about 4:09 at the least. So probably what I'll do is I'll go between 4 o'clock and 4:10 on here with some other increments. I'm going to pause the recording and figure that out, and then draw those in there. So I'll use my ruler. I'll try to find even divisions between there so I can get 10 minutes on there with maybe some smaller increments in there to help the person out who is trying to solve my problem. So I'll be right back. All right, just keeping you informed of how I'm doing this, I put my 3 cities on there. After I wrote my city names, I just decided to draw a line that's even with all 3 of the seismograms, and this is going to be 4 o'clock. The next thing I did was I tried to figure out how big I can make my minute increments. Remember, I needed to go to 4:10. I was hoping that maybe I could get to 20 centimeters on here, but 20 centimeters was off the page. So instead, what I experimented with next, I'm like, can I do 1.5 centimeters and make it work? And it did work. So what I did is I went to 1.5, so that'd be 4:01, 4:02, 4:03, 4:04, and I did that all the way down until I got to 4:10 ending here. And that's going to work because I can always go to like 4:11 or whatever. It doesn't matter. I just have to get that S wave in there, that biggest S wave, which I believe was Fairbanks. I have to get that in there by 4:09 or so. So as long as I'm not off the page with that S wave, then I should be good to go. So now I'm going to go back and fill in my minutes, and I'll update you then. Okay, I got my whole minutes on there. They look fine. And so then what I started to do down here in Minneapolis, and we'll do with the other ones too, is I tried to figure out, okay, can I give the person that's doing this the 20-second mark and the 40-second mark for each minute? And I was able to because the increment that I ended up choosing was 15 millimeters, which millimeters one of those little tiny lines on there. And so because it's 15, if I break those into thirds, each one is 5 millimeters. So because of that, it made it a little convenient. If yours works out to be the same, that's just fine for me to give them these little 20-second and 40-second marks for each minute. So I'm just filling those in right now. Okay, I have those all filled in, and now what I want to do is actually mark where I'm going to have my P wave and S wave arrival times. So for Cancun, my P wave arrives at 4:03:40, so the P wave is actually going to arrive right here. I'm going to put like a mark up here just to indicate that, and then the S wave is going to arrive at 4:06:40, so 4:06:20:40. So here's my S wave, and then what you can do is really just draw that. I'm going to draw it right now, so there's just little waves in before that, and then as we get to here, boom, we get a big P wave right there. Mark that as a P wave. And we got some shaking after that, and then boom, we get an S wave. Mark this as my S wave. And some shaking after that, and I've done it. So I will do that for the other two, and then I'll check back with you to show you. Well, really, that's like the last steps, but I'll just show you what the other person's going to have to do with this information. Okay, I've drawn my seismograms based on the data I had here for all 3 of my cities. I was looking at these. To draw them, I labeled the P wave and S wave arrivals for the person who will be solving it. We have our times down here, we have our increments down here, so hopefully they can decipher what's going on. And at that point, you are finished with the construction piece. It's going to be up to them to fill in this table, and then it's going to be up to them to triangulate that on the map that is given for them. We have one last step here, and that is to copy your map scale onto the solver's map. So I'll show you real quick how to do that. Okay, so what I'll do is I'll flip through until I find the creator's copy for the solver. And the last thing I want to do is I want to copy my scale onto there. The one thing I'm talking about here is the scale is the circled numbers that I drew on here. I do not want to put this information on there, obviously, because that is theirs to figure out. So I'm only going to copy 0, 1,000, 2,000, 3,000, 4,000, 5,000 for my person to use. And after that, they can use this data to hopefully figure out this data and be good.